Okay, in this video, we're going to look at the power rule of integration. So this is your basic integration. You may remember there was a power rule for differentiation. This is basically the opposite of that. And the first thing, the most important thing about integration is there's not a lot of rules. Power rule is really the only rule you're going to find. So when you're integrating, you may see some quotients, you may see some products. You need to know that there's going to be no rules for those. So you really have to rewrite them into the form that you can use the power rule. So you can integrate across sum and addition, just not quotients and products. So that hopefully that becomes more clear as we do this. So we're gonna look at three problems, uh, 23, 25, and 27. So let's look at 23 first. 23, um, that's not in the form that we can integrate because, again, we have to be in this form to integrate anything. So when you look at 23, you do have to use rules of exponents to make 1 over x to the fifth x to the negative fifth. Now we're in the correct form. So now this is easy to integrate. The process is, according to the formula, you add 1 to the exponent, and then you multiply by the reciprocal or divide by that exponent. I'm going to simplify just a little bit here. And you need the constant of integration. And you can think that's why it's called indefinite integrals, because you don't get a definite one single function. You get what they call a family of functions. Negative 1/4, negative 1 over 4x to the fourth plus any constant would give you a derivative of that. So that was 23. 25. Now, 25 is a quotient, and we can't integrate quotients, and we will never be able to integrate quotients. That's important. We can always integrate sums and differences as long as we can use the power rule. So what we're going to have to do with this is split it up. If there's one term on the bottom, you can split that up. So put both of them over the square root of x. Simplify using rules of exponents. Those variables must be on top of the fraction. Now you can integrate both of these terms separately. So you add 1, multiply by the reciprocal, plus add 1, multiply by the reciprocal, which would be 2, plus c. Now, for differentiation, we did a lot of simplification. We're still going to do that, not as much, but you should factor out, or could factor out 2/3 x to the 1/3, and you will get x to the first plus, we took a 2 out of that, that's a 6. We have to multiply by the 3 that we don't have, 18. This should be a 2 plus c. So that would be the simplification of that. Finally, the last one, 27. That's a product. You can't integrate a product. So what we're going to have to do is FOIL that out or distribute it out. So we have x times 3x. The middle terms will be 3x minus 2x. And the last term is minus 2. So we do have to multiply that out before we attempt to find the antiderivative or integrate. Now we can integrate or find the antiderivative of each term separately. So for the first term, you add 1 to the exponent, multiply by 1/3. So you get 1. Second one, you add 1 to the exponent, multiply by 1/2. And the third, the integral of -2 is -2x. That we normally remember, but if you want to think of it this way, it's 2x to the 0, add 1 to the exponent, x to the first, and then multiply by the reciprocal of 1, which is 1, so it's 2x. That normally you'll just remember that the integral of a constant, you just throw that x on the end, plus c. I'm not going to bother to simplify that one. There you go. Hopefully that helps. Happy integrating.